Sakurajima is one of the most active volcanoes in Japan and is one of two stratovolcanic cones, the older inactive Kidarake Peak and the younger active Midake Peak. It sits on the southern rim of the Aira caldera, the vast remains of a supervolcano that erupted around 30,000 years ago. Sakurajima was originally a volcanic island, but lava from the massive 1914 Taisho volcanic eruption filled the Seto Strait and connected it to the Osomi Peninsula.
Sakurajima rises to about 1,117 meters above sea level. While not among the tallest volcanoes globally, it is prominent given its coastal position and steep relief. The Volcanic Explosivity Index, otherwise known as VEI, is a measure of how explosive an eruption is. Sakurajima's major historic eruptions have reached VEI 4, which is fairly explosive on a regional scale. However, most of its activity in recent decades consists of smaller ash explosions and minor volcanic events, typically of VEI 1 to 3. Because of this mixed behavior, I rated it 65 out of 100 in terms of deadliness to reflect both its potential and its frequent smaller eruptions. In its 1914 eruption, which was its most devastating eruption, around 58 people died directly due to the eruption and associated earthquakes and damage. Some sources suggest a higher total when indirect effects are included, such as building collapse and landslides, hence leading up to almost 140 people being affected by this. Since then, because of Japan's strong monitoring and early warning systems, casualties have been extremely low, only 2 confirmed deaths in the modern era, one in 1946 and one in 1955 from eruptions. That's it. Sakurajima lies very close to Kagoshima City, about 4 kilometers away, home to around 600,000 people, so a large eruption could threaten many lives. Additionally, there still are chronic impacts like ash inhalation can increase respiratory disease risks in the surrounding areas. Therefore, I rated it a score of 65 for deadliness due to its overall potential effects.
The most recent eruption occurred on July 17, 2025. It produced thick ash plumes rising up to 3.3 km above the ground. Although no major damage or injuries were reported, the ashfall affected surrounding areas. Talking about devastation potential, Sakurajima's eruptions are typically strombolian to plinian, which means they can produce powerful explosions that eject volcanic ash and gas high into the atmosphere. These materials can contaminate water supplies and damage crops across the region. Since Kagoshima's economy largely depends on agriculture and fishing, an eruption from Sakurajima could severely disrupt these activities by covering farmland with ash and disrupt marine life around Kagoshima Bay. Although Sakurajima's effects are mainly regional rather than global, a large-scale eruption could still temporarily disrupt air traffic and contribute to short-term atmospheric cooling due to the release of volcanic aerosols. Overall, the combination of the variety of hazards it produces and its potential to disrupt both the environment and economic activities justify a high devastation potential score of 75 out of 100.
Volcanic activity at Sakurajima can be divided into 4 main stages, from the Kitarake eruptions over 20,000 years ago to the ongoing eruptions at Minamidake and Showa craters today. Sakurajima's eruptions show no patterns and fixed cycles and alternates between long periods of dormancies and centuries of intense activity. In the last 500 years, Sakurajima has entered a highly active phase and is currently the most active volcano in Japan. Largely small eruptive activities have been recorded each week. Sakurajima is closely monitored in real time by the Japan Meteorological Agency and Kyoto University. Strain and seismic data are the 2 main monitoring methods at this volcano. More than 18 seismograph stations and 24 GPS sites track ground movement, earthquakes, and magma flow. Scientists can detect ground swelling and small quakes just before explosions, helping to forecast small short-term eruptions. We rate Sakurajima's unpredictability at 60. While it is well monitored and small short-term eruptions can be anticipated, predicting the next devastating eruption like those in 1471, 1779, and 1914 remains difficult due to irregular major eruption patterns in the past.